are the definition of basic components like capacitor, resistance, inductors, okay, and how we will derive different expressions and formulas from these basic components. So first definition we have discussed in the last session is capacitance and how to calculate the charge of that particular capacitor. Okay, so we have calculated the charge C is equal to Q upon V. Then we have seen the definitions with the help of some circuit diagram, and we have calculated the work done. Okay, after that we have seen different current sources. Okay, so firstly some ideal sources we have discussed. So what are those ideal sources? Those ideal sources represent where there is no losses in the circuit. Okay, it will give you the proper ideal output. Okay, so that is called the ideal current source, where we have seen practical current sources. So what do you mean by practical current source? Practical current source means when there are some losses like internal resistance is there, heat dissipation is there, so it will not work according to the desired output. Okay, it will lose some output. So that is called practical uh, current source. Okay, we have seen the symbol of inductance, and we have seen a lumped network, distributed network. So what do you mean by lumped network? Lumped network means that when we remove or we can separate resistor, capacitor and inductor from the circuit, whereas in distributed we cannot separate them. After that, what are the passive element? Okay, so a network containing circuit element without any energy source, that is passive element, whereas in active we have some energy sources, and a linear element where the constant factor is involved is called a linear element. So then we have seen voltage sources same as the current sources, but the basic difference is that the representation is different right here. Okay, so same thing we have discussed right here. Then we have seen what are the different nodes, branches, essential node, essential branches. Okay, then we have seen the circuit in which we have find out how many nodes are there, like A, B, C, D, G. These are the nodes. Okay, so these are some nodes. Then essential node is B, C, D. These are essential node. Okay, then we have seen branches. So these are branches A, B. Okay, A, G, B, G, B, C, C, G, C, D. So first thing you will tell me how many voltage sources? Voltage source. How many voltage sources? B1 and B2. Yes, two voltage sources are there. Second thing you will tell me how many resistances. Resistances, how many resistances? R1, R2, R3. Three resistances are there. Then you will tell me how many inductors. How many inductors are there? L1, L2, two inductors. Yes, you are right. Then you will tell me how many capacitors are there? Only one capacitor is there. Yes, you are right. Now you will tell me how many nodes are there? How many nodes are there? Okay, how many nodes are there? This is one node. Okay, A. Then B is also node. Okay, C is also a node. D is also a node. Okay, and lastly G is also a node. Okay, so you will write A, B, C, D, G. Okay, 1, 2, 3, 4, 5. Essential node is that where three or more elements are connected. Node is where two or more elements are connected. Three essential nodes are there. So what are those essential nodes? I have explained right here. Okay, so those three essential nodes B, C, and D. Okay, these are three essential nodes are there. Okay, first we will represent AG, then we will start from this AB. Okay, AB is also a branch. Then we will start from B to G. B to G is also a branch. Okay, then B to C, this and this. B to C is also a branch. Okay, then we will start from C to G. Okay, C to G is also a branch. C to G is a branch. Then C to D is also a branch. Then D to G is also a branch. Then D to F. Okay, D to F is also a branch.